Welcome to Dose Grid. In this video, we're going to take a look at field size, flatness, and symmetry, and explore the question, how do we describe the shape of a radiation beam? Let's review how we measure beam profiles. Here we have an idealized water tank and a detector moving across a radiation beam. And we can see, generally, there's a flat region, and then we have penumbra. Let's take a closer look. Here, we have a radiation beam profile. And at the 50% isodose line, or the full width half max, and that's where we define our field size. It's not the size of the physical collimation, rather the width, dosimetrically at the 50% isodose line. And if we measure that same beam profile at different depths, we will have a different field size. So typically, when we define a field size, we're talking at a particular depth, isocenter. Also notice that the penumbra, or the shoulders, changes as well as we go deeper in. This is due to increased scatter. Now let's take a look at symmetry. In an ideal world, our beam would be perfectly symmetrical. And this is a measure of how close we are to the ideal. Here we have variance point definition. We take a look at points to the left and the right, equal distance from the center, and look for the max. The other definition is an area definition, where you look at the area, the left and the right. Next, let's review flatness. Flatness is a measure of the variance, or the max or min intensity, of the useful part of the beam. Nowadays we use array devices, ion chamber array devices, and this is probably the more common one, the IC profiler. And each kidney bean type is a ion chamber. And in the software, it's important to look at the different protocols for the analysis. And here we have a real beam. Let's take a look. We have a 10 by 10, a 25 by 25, and a 30 by 30. And we can see the software spitting out the flatness and the symmetry. Now, it's important to understand your manufacturer's specifications. For example, Varian specifies for photons less than 3% flatness at a particular reference condition. For a profiler, that is typically 9 cm of buildup on top and 100 SAD. Symmetry, they specify less than 2%. For electrons, it's different. Symmetry is still 2%, but the flatness can be as high as 5.4.